Okay, so today's plan. Today's plan is basically to work over JSDocs because right now I have stopped a lot of things, but there isn't a lot of JSDoc around, and JSDoc would be very useful for people coming over the project. So what I'll do today is have a look at the entire code base, every method, check out if it has JSDoc or not, and eventually add it whatever is missing. And I will also keep track of additional things to do. So I'm gonna open GitHub, okay, just to have a window where I can record things I see while looking into the code base. And when I see something I don't like, I'll keep track of it. Okay, so last time I probably started working over the poison pill. Maybe I should give more description what a poison pill is. So a poison pill is a special value that tells the behavior entity to shut itself down. A poison pill is handled only when you actually use. Hey there. Hi Mike. How's it going? So poison pill is handled only when you are using a queue-based recipient behavior. And that's basically because we have different kind of recipient behaviors, and that is basically the next module we have to yeah, exactly. Poison pill is only when you are using a queue-based recipient behavior. Perfectly. That's because other recipient behaviors such as from function effect would not care about poison pill. Okay. So that is basically telling that if you're using a recipient behavior that is from in-memory queue, this will actually tell the behavior to shut down itself. From function effect wouldn't, because from function effect is thought as a behavior that basically does the stuff and shut itself down immediately. So the entity actually spawn up every time. And if you want something that is more persistent, you actually have to use a queue in order to control the lifetime of the queuing of the messages, etc. Okay, so make construction new poison pill. This is right now an effectful operation. Yeah. Checks if the given value is a poison pill. Nothing more. And this is a schema for a poison pill that is used to encode the value over the wire. So, okay. That is because poison pill can be part of your recipient behavior, so can be part of the messaging protocol you have with an entity. So maybe I can also say that. This is useful if you want a behavior that can be shut down from an external message. So you can effectually use this as a message. Okay, take or interrupt attempts to take a message from the queue if the queue that the same way the queue.takes does. If the result is a poison pill, we will interrupt the effect. Okay, this is just a utility, can be implemented. Yeah, got alive those poison pills, yeah. This is effectively just a utility, can be implemented also in userland, but why not? It's just 2 lines of code, so this is basically will take from the queue that we will receive from your in-memory queue behavior, and then it will basically call interrupt whenever is a poison pill or not. Okay, so this module is done. Okay, a recipient behavior. Right now, the entity behaviors are represented as effects that will return a function, and I'll come back to this later. And these effects have as context whatever they want, plus they have a recipient behavior context, and they are controlled by a scope. Basically, the scope is closed whenever the sharding or the cluster wants to kill the entity, the specific entity. From outside, it will close the scope. So basically, every resource you have in the effect will be interrupted and whatever. Also, what it returns is a function that takes in a message and returns an effect that returns basically how the message has been processed, or an exception while offering the message. So basically, this is what I call offer usually. And offer is basically a function that takes in the message and returns if the message has been processed or not, or just acknowledged. And this is one of the things that I am still thinking about alpha, because it's something that maybe I would like to change, but right now I didn't came with something better than this, because I didn't want to force people to have queues. If you want some behavior that is just ephemeral, that does something and shutdowns, I'm okay with that. And this kind of signatures allows that, but I need to tell the users more about this. Okay, so our recipient behavior describes how a specific entity type should be a recipient type, to be honest, because can be also a topic. Type should behave. Okay, this is the actual implementation of what an entity should do. Oh, you're right. Now we're talking. Okay. So this is the actual implementation of what an entity should do upon receiving a message, this is what an entity should do upon receiving a message. This could require additional context. So this could require additional context, and the lifetime. Maybe okay. This could context. Okay, and that's it. Okay, and now I will say about why there is a scope in there. So the scope provided in the context is controlled by the cluster, EntityManager, and is used to request the shutdown of the entity. Okay, so you can safely scope whatever source you want, and the entity manager will clean it up for you. Okay. You want, and the entity manager will close the scope for you when the entity is shut down. When the entity is shut down. Okay. Okay, so let's try to read that again. A recipient behavior describes how a specific recipient type should behave. This is the actual implementation of what an entity should do upon receiving a message. This could require additional context. The scope provided in the context is controlled by the cluster EntityManager and is used to request shutdown of the entity. So you can safely scope whatever resource you want to use for your behavior. And the EntityManager will close the scope for you when the entity is shut down. Okay. And now I also need to add something about telling what the return value actually is. Okay, so the function returned by the recipient behavior is what we call offer. The function returned by the recipient behavior effect is... Oh, hi there! Nice to see you back. Okay, the function returned by the recipient behavior effect is what we call offer effect. Okay, so the offer effect is what the entity manager calls to hand messages to the behavior, maybe. I'm not sure if it's clear what it does. The offer function is used by the entity manager to give messages to the behavior. So basically, there is like two phases. There is the offer one, well, where the messages is hand off to the behavior, and the behavior upon offering can return whatever the state of that message is. So basically the behavior can say, okay, I just received the message, I acknowledge that I received the message, do nothing more, I'm fine with it. Or the behavior can already reply with the actual result for that message, because maybe it can process that message immediately. And this is what I called before ephemeral behaviors. Basically, ephemeral behaviors only implement this part of the behavior, only the offer function, and doesn't care about the lifetime, because they will eventually be spawned up there and killed immediately. Okay, so the function returned by the recipient behavior effect is what we call after effect. The after effect is used by the entity manager to give messages to recipient behavior. Okay, I think that this is more than enough. Okay, right now I have this kind of option that I'm looking towards find a way to put somewhere else. I would like this to be a combinator of the recipient behavior instead of being an option, but I need to find out more how can this become a behavior. Basically, this is the entity max idle time, which is basically the max time that can pass between one message being processed and another. After that time expires, the entity manager will try to shut down the recipient behavior for that specific entity, because basically that entity is doing nothing, so it doesn't make sense to have an entity in there. So right now, maybe I'll add something about this, but I really want to kill this. Okay, these are the options for an entity behavior. This control entity model time and check out more on that over. This is already documented elsewhere, so maybe I check out more on that over the sharding config. So this allows to override the setting for a specific entity. So if you have an entity that takes a lot of time spawning up and takes a lot of time going down and doesn't receive a lot of messages, maybe you want for a specific entity these settings to be higher, so the entity manager doesn't try to kill that behavior so frequently. Okay, from function effect. If I remember this correctly, and I will check it out, this from function effect is just what I said before. Okay, this is the simplest implementation of a behavior that basically, given an entity ID and a message, will return the message state, which is basically if I process or not the specific message, never, and requires only error. Okay, and this has no resources. This has no lifetime. So basically, it will be killed whatever the entity manager wants to. Okay. This is the simplest behavior you can implement. You can have. You provide function that given the entity ID and the message itself, it will immediately process it. Okay. You are then required to return a message state to tell the caller if the message has arrived and processed. Okay. So this is the simplest behavior you can have. You provide a function that given the entity ID and the message, it will immediately process it. You are then required to return a message state to tell the caller if the message has just arrived and will be later processed, or it has been processed. Okay. And then we have from function effect stateful, which is basically the same thing, but here you have an initial state function that given the entity ID will return the initial state you want. And then you will also have the same way as before an handler that takes the entity ID, the message, and a ref to that state you had before, and will basically process this. Okay, so this is a stateful version. So this is basically a stateful version of from function effect version of from function effect. You can provide a function to get the initial state, and you can provide a function to get the initial state. And then it will be passed as ref. Maybe it's better if I specify that everything here is performed in memory. Everything here is just stored in memory. So if you have some transient entity or something that requires maybe some in-memory state, you can use this. Everything here is just stored in memory. So persistence, so eventual persistence of the state is up to you. Okay, and finally we have from in-memory queue. And let's see how the implementation was. Recipient behavior. Okay. Okay, this is a little more complex, but what basically does, it creates an unbounded queue with either the methods or the poison pill we have seen before. And then you have poison pill on make. Okay. Oh, this is the offer function, yeah. Which basically offer the message to the queue and I wait for the shutdown to be completed, which is just a deferred that will complete when the shutdown is completed. Okay, behavior started. Okay. I handle the message. Oh, I call the handler, okay, and the handler now will have the queue and a reply function, yeah, that will basically tell for that message, which is the message state, okay, and this part is, this is the actual implementation of the offer, okay. If already have in the cache the message state, I return the same message state, otherwise I just call queue the offer, okay. So this has a little bit of logic more than the other ones. Okay, so this behavior uses a queue. I'm not sure if you already had from effect, but if not, you could drop the function from the names from effect stateful. Yeah, that could be a thing. Yeah, right now it has function because before I had a from effect and basically had the message and the entity ID in the environment instead of as a parameter of a function. But yeah, I could see that being something. Yeah, let me add that to the things I need to do. Consider renaming from function effect to just from effect. Okay. Yeah, basically before I had that variant that was just called from effect, and the message came from the environment. The thing is that then the environment had a service that had a generic type, and I am not a big fan of those. I know that those can be done, but I'm not a big fan of those. And so that's why for now I had them called from effect. But yeah, I already tracked that. I need to rename those. Okay, so this behavior uses a queue where the entity will accumulate messages to be processed, and then you can use the queue to take message from that and process that. Okay. Poison pill is provided. Okay. A poison pill is provided to request interruption of the entity behavior. Okay. Okay, and I think there is nothing more in here. Okay. Okay. Okay, recipient behavior context. Recipient behavior context is basically the context is provided to a recipient behavior, and right now has some things that are kind of the same that you can have in your behavior, but they are useful because they are expected to be just information of where the behavior is running. For example, you have the entity ID, the shard ID for the specific entity, the recipient type. So if you write generic behaviors, you don't have to explicitly pass in the recipient type because you can read that from the context. And you can also have the fork shutdown, which is basically a way from within the context request the shutdown of the entity. So if for some reason you detect that the entity is processing something that is not correct, or something that you want for some reason to just shut down this entity right now without waiting it for going into an entity idle timeout, you can basically do that by just calling recipient behavior context.fork shutdown, and the entity manager will shut down as soon as possible the behavior. So blah, 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 blah. This is something that I don't care about. Okay. And I can say, this is the context information that is available. Okay, that is available to the behavior context. Behavior, recipient behavior. And has general information about this specific entity, like the entity ID or the recipient type. And now you see why I said before that I wasn't sure about keeping information in the context or having that function that receive messages, because actually you already have here the entity ID, so you can get it yourself from the context. But yeah, it's easier to just type a function that has a parameter, the entity ID, instead of getting that from the context, which will be an effect. So yeah, I'm still unsure about that. I'd prefer more the context way, which is more effectful way to do that. But yeah, I could see people saying that, yeah, writing something like, for example, I have test in here, writing behaviors that maybe sharding tests. Okay, from function effect, writing behavior like this, from function effect entity message, and say if the entity D is blah, do this, else do that. Yeah, this is way simpler of accessing the tag, reading the entity, flat map it, and then yeah, whatever. Yeah, you can also use effect gen, and now it's even easier thanks to latest changes of that. But yeah, I'm still unsure about that. Okay, so back where it was. Okay, tag to recipient behavior context. Okay, nothing more to say about this. Creates a new recipient behavior context. Okay, this is just those are just the utilities to get the current entity ID, the current shard ID, the current recipient type. Okay. And this forks the shutdown of the current recipient behavior as soon as possible. Okay. And I think that this module is almost complete. Okay, so next one. Recipient type. Okay, recipient type. What is a recipient type? Basically, in cluster, we have two kind of recipients. We have an entity type recipient and a topic type recipient. Basic difference is that the entity type can live only on a single pod at a time. The topic type can live in many pods at a time. That's it. So one is a topic, so it's just receiving information, and the other is an entity, which has constraints of being alive only in one point of time, etc., etc., etc. So another thing I see in here is that I used interfaces back then, but right now maybe I should move to I should move to maybe data, yeah, effect data, yeah. This is something that I don't move over the wire because it has the schema wire in itself, so I can't move it over the wire. But yeah, make entity type, name and schema, yeah. Oh yeah, definitely. I should. Yeah. Okay, another one issue, new issue. Okay, and this is rewrite recipient type to be effect data instead of interfaces. Rewriting to effect data instead of interfaces will also give me the ability to have equals working for them, because when I want to compare if two recipient type are the same, what I care about is just the tag and the name, and I don't care about the schema. So yeah, that could be a good reason to move into those. Yeah. Okay. So entity type. An entity type is a recipient type that is ensured to be alive only on a single pod at a time. And the topic type, a topic type, topic type, a topic type can live on multiple pods, on the same time, at the same time. Okay. So a recipient type is basically either an entity type or a topic type. Okay. A recipient type is basically a pointer to class, to a grouping, to a logical grouping, maybe, yeah, a logical grouping of multiple entities having the same recipient behavior. So if I have a pointer to a recipient type, I can basically message with whatever entity you want of that type. Maybe I should write this as well. Okay. This value is required to be able to message with an entity or topic, since it holds the schema, holds the schema, since it's all the schema for the messages over the wire. Without that, without the schema, you cannot, without the schema, you cannot basically have assurance that the sender and the receiver are speaking about the same kind of messages, so you can have inconsistent messages. So yeah, without the schema, you cannot ensure that the messages sent are what the receiver expects. Ideally, you can share this definition. So ideally, you can share this definition of the recipient type either between a consumer and a provider of a behavior. You can share the definition between the caller and the receiver. Okay, this is basically the contract. Is the type suffix necessary? Not really. It will be recipient. It'd be a recipient of a message. Oh, also, hi there, Federico. Yeah, it's not strictly necessary. Then it could be recipient. Yeah, and the recipient can be either an entity type or a topic type. Yeah, that could be a renaming. I'm thinking if that. I'm thinking if that could cause some confusion with the people, because the wording type means that is not a specific recipient, is not a specific entity. This is not representing a specific entity, user number 1 or user number 15. This is representing the users, okay? And then after you have the recipient, you need to also provide the user ID if you want to message with a specific user, okay? The recipient, the type word means you have this class of behavior of recipients that are of kind user, or that are of kind to do, or are of that kind purchase. But yeah, we could consider maybe a different naming instead of type something else. Recipient. I don't. I don't have a better wording for that, but definitely open to some better wording for that. I see your point. You're saying, yeah. Yeah, exactly. I see the point you are saying. To me, the type seems something abstract, and then I expect something more specific implemented. Yeah, I see your point. This is more recipient kind, maybe. Yeah, I see your point. I'm struggling to figure out a different kind of naming for that. Basically, here I want to say that, yeah, this is a class of users, this is a class of to-dos or whatever, and this is not the specific user or the specific to-do I want to interact with. That can be renamed maybe a recipient kind. Not sure if that would work better. Okay, so now we have make entity type and make topic type. Okay, and basically these are constructor given a name and a schema for the protocol, constructs an entity type. So this is basically the constructor you have to call given the name and the schema, which is represent the. Maybe you can move the discussion to initiate. Yeah, and keep the conversation. Yeah, I think that I already created an issue right now. Oh no, I can create a new issue. I was sure that I created that. Okay, so consider renaming recipient type to something better. I definitely opened an issue, so if someone wants maybe to propose a different naming, I was thinking about recipient kind, maybe. But yeah, definitely open for new better proposal. Oh, you're welcome. Okay, so topic type, mostly the same thing, given the schema wrapper, construct a new topic type. And then you can refer to topic type. Topic type can live on multiple pods at the same time. Okay. Okay, and get shard ID, get the shard ID where this entity should run. Okay. Okay, serialization. Okay, this is something that I'm considering dropping. This is basically the trait, the context service that defines how messages are encoded and decoded. But to be honest, I am considering completely dropping this since we are so tight with FS schema and we are in a JavaScript environment. I was actually considering just relying on JSON and that's it, because I don't see use cases where you want your messages over the wire to be in a different format than JSON. And to be honest, in the end, maybe you can just I use in the end just a serialized message, and the serialized message basically has a string in it. Yeah, serialized message. It is basically already encodes for you the value in itself. So yeah, I was considering dropping this and just use JSON by default. So maybe I'll move this one later, but yeah, it's already at least something documented. Okay, serialized envelope. Okay, so serialized envelope. Serialized envelope is the envelope that is posted between different service, between different pods. When you send a message from one pod to an entity that lives on another pod, what happens is that the message is encoded and you get back a serialized message we have seen before. And then move it then, or maybe let it open to implementation. JSON is the default, and then you can customize it. Yeah, yeah, just yeah. This is the kind of implementation we have right now. You can change the serialization, but in the end, the thing is that yeah, I'd love to see protobuf as well. Yeah, the thing is that in over the end, what happens is that everything is put into a serialized envelope. So yeah, we can left that open for now. Yeah, I could see protobuf being something. Yeah. Also, there are other message pack, for example, message pack. Yeah, if I remember correctly, or binary JSON B. Yeah, maybe I can. Yeah, message pack. Yeah. For now, I can keep this. Yeah. I just need to rework it a little because I'm not completely satisfied with it, let's say. Because I encoded the value as a serialized message, but then what happens is that the pods trait, which is what send the message, used a serialized envelope, and the serialized envelope in itself has the value I've serialized. Yeah, yeah. I see. Unfortunately, I consider dropping JSON for server to server, but I see why. Yeah, the thing is that given in order to make cluster work, you have to have basically two different environments that are already JavaScript environments, because you need to have cluster running on one side and cluster running on the other side, and being JSON something so basically spread inside the JavaScript environment, and being something that is just how the pods communicate between them, something that is not exposed externally. Yeah, exactly, Mike. Protobuf requires a spec, so I'm not sure it can be done dynamically. I started thinking about that when I started writing cluster, but the thing is that later I figured out that in the end, even if you use protobuf or whatever, if you think about it, if we were writing something like low-level code, we would just have bytes and send bytes from one side to the other. And then the deserialization trait is something that decodes the bytes you received from one side and encodes the bytes you have sent from the other side. And so I was thinking that maybe I could consider the JSON as the bytes instead of a string or a byte itself. Yeah, then you need a schema registry, or maybe you would need to put additional annotations over your schema. And yeah, I also the additional instrumentation and the code that would be required to serialize to protobuf and then deserialize. Yeah, I think that in the end, maybe just sending JSON would be faster, maybe. Not sure, but you need to do some kind of real testing to ensure that. But yeah, in the end, maybe just sending around JSON is it. Yeah. I spoke about byte arrays as something that if we are not in JavaScript, if we were writing some low-level system that is not cluster, basically bytes would be something that is the most low-level you can go, and ensure that you can plug in whatever whatever you want to. And in a JSON string you can encode bytes too via, yeah, exactly. And that's the point. Right now I have a string. I am sending from 2 endpoints a string, because I think that the string is basically the most low-level primitive you can have, that 2 different endpoints can share and send between. And inside the string you can do whatever you want. As you pointed out, you can even send encoded bytes into a string. So I was thinking about dropping it and using just schema and using JSON as basic value. Yeah. Also, the thing is that schema by effect schema by default puts into the encoded side everything as JSON safe. So for example, dates or whatever, they are converted in the encoded side on something that is JSON safe. So even the schema having a schema is something that is already enough to describe something that needs to be serialized over the wire and then deserialized over on the other side. So yeah, that's why I was planning on maybe dropping the serialization trait and just use a schema in JSON. That's it. So back where we were before. Okay, when we exchange, I was saying that when we exchange messages between different pods, we use the pods trait that calls send and get message. We have a destination pod and we have a serialized envelope. The serialized envelope is basically the message plus some information of where the message should go to the destination pod. Is basically the routing. So basically the serialized envelope has the destination recipient type, the destination recipient entity ID, the message ID itself, and this is an addition I did recently, and also the body of the message itself. And here we have the message, as we have just discussed, as something that is serialized, because here we are basically exchanging things between pods, and we cannot know if the remote pods knows how to deserialize. So basically we just send the serialized message, and the remote pod, if knows about these specific entity types we are speaking about, will use the registered entity schema to decode the value inside the body. Okay. And also something that I would like to is that this serialized envelope right now can maybe extend the request trait from effect, and maybe can be used as an effect request, because this class has the destination address, which is recipient type plus recipient ID, and also has the message itself. So I know where to route it. And that's why I was considering maybe make this extend schema effect request as well. So user can just yield serialized envelope, and that's it. And another thing that I was considering is that instead of calling it serialized envelope, I could make this a generic class called envelope of A, and an envelope of A is just the recipient address plus the message of type A, and then I can construct a serialized envelope being envelope of serialized message. That was something that I was considering. Why I was considering this? Because then I can write the recipient behavior instead of just being a behavior of message that received the message. I could write the recipient behavior to be something that receive an envelope of a message. So then inside the envelope, I could put information like, for example, the trace ID of the OpenTelemetry for the sender, and then the receiver can maybe inject that into the OpenTelemetry in order to resume the and connect the OpenTelemetry and things like that. That was one point I was thinking about. And right now it's called serialized envelope, but like I was saying before, I would like to call this envelope of A, and then have A be whatever the kind of message you have. And when pods exchange message between them, the A would be a serialized message. I think that I will go that route, yeah. The more I speak out loud about it, the more I think that is the correct way to do. Yeah, serialized envelope is too specific kind of envelope, and there are so many possibilities for so many information I can put in the envelope, and there are information that are mostly statistic ones, like for example the creation time of the envelope, and is something that the sender can inject, and is something that the user can decide if want to rely on that or don't, because that would be exactly the time that the message has been created from the sender. So each time the sender retries to send the message, the creation of the envelope would change. Yeah. Okay. So back to documenting things. Okay, serialized envelope. A serialized envelope. A serialized envelope is the message that goes over the wire between pods. Inside the envelope, you have the encoded message plus some information on where it should be routed to. And also the other thing is that if I have envelope, the thing I would have is more recipient behavior utility function that enhance a behavior. Like, for example, I already have at least ones that relies on having recipient behavior or serialized envelope. Yeah, if I make this more generic, here instead of requiring a recipient type, a sharding ID, an entity ID, etc., I could just take as a parameter an envelope, and that's it. In the envelope, I already have everything. Okay, so back, construct new serialized envelope. Okay, that's it. Is serialized envelope ensures that the given value is a serialized envelope. Okay. Serialized message represents a message that has been serialized. Okay, shard ID, if I remember, I already did that. Okay, let's try to read that again and see if something is missing. Okay, a shard a shard is a logical grouping of multiple entities. There could be thousands of entities in your system. So instead of managing every single entity ID, the shard manager groups them by shard ID. And when they are assigned or moved around, we always move all the entities with the same shard ID. Okay, and this is tied to the concept that tracking each single instance of each entity type you have in your system would be too much. And so what we do instead is create a group of entities IDs, and those grouping are called shard IDs. And effectively, as we've seen before, they are effectively implemented by just taking the hash of the entity ID and then modulo the number of shard ID you configured you want to have in your system. And then whenever we do assignment, etc., we speak about shard IDs instead of specific entity IDs. Okay, construct a shard ID from numerical value. The shard ID is currently built up by making the hash of the entity ID and then the modulo of the max amount of shard configure manager config. Yeah, this is exactly how it works. Okay, sharding. Oh, this is a tough one, but if I remember correctly, this should be already almost documented. Okay, tag and live. Okay, notify the shard manager that shards have been assigned to be this pod, register. And unregister does the opposite thing. Notify the shard manager that shards must be unassigned from this pod. Okay, and then we have register scoped, same as the register, but we automatically call unregister when the scope is terminated. Okay, and then we start the specific cluster method. So register singleton, start a computation that is guaranteed to run on a single pod. Each pod should call register singleton, but only a single pod will actually run it at given time. Okay, so this is tied to the concept that right now a cluster requires that all pods knows about all the entities. You can have right now unbalanced pods that knows only about specific kind of entities and not about others. That could be implemented ideally in the future, but at the moment I don't see why that should be the case. At the moment I want to focus on everything being the same and basically developing your system thinking about there is only one pod, and eventually that could be 1,000 because you can scale out the number of pods you have. Okay, register entity registers a new entity type allowing pods to send messages to entities of this type. Okay, register topic. Registers a new topic type allowing pods to broadcast messages to the subscriber. Messenger. Get an object that allows sending messenger to a given entity type. You can provide a custom send timeout to override one globally defined. Okay, so when you have an entity type that we have defined before, you can then request a messenger object using a messenger, and using that messenger object you can send messages, either send or send discard messages to entities. So you need to basically to message to an entity you need to have the recipient type as we have seen before, okay, because you need to know to which kind of entity you want to speak with. And then given that, you receive back a messenger. A messenger is able to communicate with whatever entity you want of that specific kind. And then inside the messenger, you can decide if you want to send a message and don't care about the result. Just return when you know that the receiver has received the message and is okay with that. Or you can send a message and wait for the response. Okay, the same goes for the broadcaster. Okay, the broadcaster get an object that allows broadcasting message to a given topic type. You can provide a custom send timeout to override the one globally defined. Yeah, this send timeout is in there because obviously you can send messages from one pod to another entity that lives on another pod. and that means that network may be unreliable, so the sending will be retried a lot of times, and eventually there is a default timeout after, okay, I wasn't able to send this message to that specific entity, and then it goes on timeout. And to be honest, we could consider dropping this one because we already have um, effect combinators for timeouts, so we can consider dropping the timeout and just thinking about sending messages will be retried forever. But I am concerned about people don't thinking about it, leading into situation where the application is basically stuck because messages are being trying to be sent forever. So yeah, I'm little unsure about that. I'll add that into my list of things to consider. Why not? Right? Yeah. The thing is that I am right now. The send timeout is there to basically. Oh, you mean the concern about the message? Yeah, the message being returned. Yeah, exactly. You're right. You're right. Where is the best point to write about it? Yeah, I can write it. Yeah, in the messenger because people will indeed use the messenger, so I can write about this in here, right? Because I can write that point in the documentation where you define the default setting for the timeout, but I think that if I write that over into the sharding config site, I think that people will use just the default sharding config without caring about the specific settings. So I think that they they won't care about this one. Okay, so maybe I can write that into the messenger, I was thinking, because this is one point where ideally people want to send message. Yeah. Send a message and wait for the response. Okay. Remember that due to network being unreliable, the sender may attempt to send multiple times the same message. Okay, you can use effect timeout to get send timeout. The full behavior, the function is to return the fidelity. Yeah, this is the behavior I'm considering. Yeah, exactly. Right now, I'll write the documentation on the opposite side saying that remember the sender may attempt to send the multiple the messenger may attempt to send the multiple times the same message. Okay, the send timeout is exactly there to prevent indefinite send definite sending of messages. But yeah, I will definitely take your description and put it inside of the issue I was writing down. New issue, open blank issue. Okay, consider defaulting send message to indefinite retry. Okay, and I'll just rewrite you can use effect timeout. I also like that more because that will get me rid out of one kind of exception I have right now, which is a send timeout error exception, and just let the user think about it. If the user doesn't care about timeout exception of sending because maybe the user runs the cluster on a single process, so there is ideally no send timeout, or the user knows that the network is so good that is maybe a local network that is so good that is difficult, that is unreliable. Yeah, I definitely like that solution a lot more. Yeah, you can definitely the default behavior is to send the message indefinitely. I'll also copy and paste this piece of documentation also on the broadcaster, because I think people will use both of them and they are basically doing the same thing. So yeah, but yeah, the more I think about it, the more I think that I will drop the send timeout exception and just be the behavior of retrying forever. Maybe I can write some log error or something when I see that I have retried the same message for 20 times or whatever setting you put into your sharding config, and log to error, log something when it does, or die once that happens. Yeah, but I think that retrying forever is a nicer behavior. Okay, so get posts. Get the list of pods currently registered to the shard manager. Okay. And then we have send message to local entity manager without retries. Yeah. This is something that is used basically by the services that implements communication between different pods. And this is used inside of them to send a message to the local entity manager pod without having retries implemented, because retries are implemented on the caller side. Send a message to local entity manager without performing retries. Those are up to the caller. Okay. Get the list of shard IDs assigned to the current pod. Yeah. That's perfect. Okay. Sharding config. Sharding configuration, number of pod shards, host name IP address of pod user for pod. This I think that this for a shard manager is not GraphQL, is REST API. Shard manager API. That's server version, time of activity, time we give to an entity to termination before interrupting it. Runtime case of failure getting a shard. Interval to report unhealthy pods to the shard manager. Okay, I think that everything in here is documented. Okay, defaults provides the default values for the sharding config. And with defaults is basically provides the sharding config. This is the same, but provides the sharding config values that are omitted will be read from the defaults. So whatever you don't provide will be used the default instead. And this is just the entire defaults. Okay. Maybe I can drop this, and maybe this may make it optional parameter. Yeah. Okay, and then we have from config reads the sharding config from the effect config provider. So you can use env, text files, whatever effect config provides you. Okay, sharding events. Sharding events. These are the events that are emitted whenever something happens over the sharding manager. maybe like I'm writing in there. Okay. These are the events that may occur over the shard manager during its lifetime. So basically, we have shard assigned, shard unassigned. We check the head pod. We have new pods registered or pod that has been unregistered or whatever. And now we have to document the constructors, constructs the event that occurs when new shards are assigned to a pod. Okay. Constructs the event that occurs. Okay, I was losing time. It's time for me to go. Thanks everyone that joined the stream, and hope you have some fun. And thank you all for all the feedback you gave. And thank you very much for being here in this short streaming. And I think that I will try to do more of those in next days. Thank you again, everyone. See you next time. And also, Efficator die every day.